The sum of the areas of all the surfaces of a three-dimensional figure is known as its surface area. The surface area is measured in square units, like centimeter square and meter square. The space enclosed by a three-dimensional figure is known as volume. Volume is measured in cubic units, like centimeter cube and meter cube. Tap any of these three-dimensional objects to know their surface areas and volumes. A three-dimensional figure with 6 rectangular faces is known as a cuboid. Each side of a cuboid is called a face that has the shape of a rectangle. The corners of a cuboid are called the vertices, and the line joining two adjacent vertices is called an edge. A cuboid consists of 8 vertices and 12 edges. The total surface area of the cuboid will be the sum of the areas of all 6 rectangles, which are its faces. So, the total surface area is equal to 2 into LB plus BH plus HL. Here, L is the length, B is the breadth, and H is the height of the cuboid. The lateral surface area of the cuboid will be equal to the total surface area of the cuboid, excluding its top and bottom face. Think of it as the area of the walls of a room, without the floor and the ceiling. The volume of the cuboid is L into B into H. The length of the diagonal of a cuboid is the square root of the sum of the squares of its sides. A cube is a special case of a cuboid, with all edges of the same length. Thus, a cube has 6 equal square faces. In a cube of side A, the total surface area is equal to 6 times the area of one of the square faces, that is, A square. The lateral surface area excludes the areas of the top and bottom faces, and so is equal to 4 times A square. The volume or capacity of the cube will be a cube. The length of the diagonal of a cube is equal to square root 3 times A. A three-dimensional figure made of 2 parallel flat circular bases that are attached by a curved surface is known as a cylinder. For a cylinder of radius r and height h, the area of the base is equal to the area of a circle of radius r, which is pi r square. The curved surface area of the cylinder is equal to the perimeter of the base into the height of the cylinder, which is 2 pi rh. The total surface area is thus the sum of the curved surface area and the areas of both surfaces at the top and bottom, that is, the circular ends. The volume or capacity of the cylinder is equal to the area of the base into height, which is equal to pi r square h. The three-dimensional figure made of 2 coaxial right circular cylinders of equal height but different radii is known as a right circular hollow cylinder. Let us consider a hollow cylinder with external radius r, internal radius r, and height h. The area of the base at each end can be calculated as pi r square minus r square. The curved surface area is the sum of the external surface area and internal surface area. The total surface area is the sum of the external surface area, the internal surface area, and the areas of both ends. The volume or capacity of this hollow circular cylinder will be equal to the volume of the external cylinder, from which is subtracted the volume of the internal cylinder. The three-dimensional figure with a flat circular base rising in a curved surface that slants to a single vertex is known as a cone. A cone is called a right circular cone if its axis, the line joining the center of the base circle to the vertex, is at a right angle to the base. Let us consider a right circular cone with height h, slant height L, and radius r. We can find the slant height using the Pythagoras theorem. The curved surface area will be pi r L. The total surface area will be the sum of the curved surface area and the area of the base. The volume or capacity of the cone is equal to 1/3 the volume of a cylinder of the same radius and height. A sphere is a three-dimensional curved figure described by a set of points that are at an equal distance from a fixed point. The fixed point is known as the center of the sphere, and the fixed distance is known as the radius of the sphere. Let the radius of a sphere be r. The surface area of the sphere is equal to 4 pi r square, and the volume or capacity of the sphere is equal to 4 by 3 times pi r cube. A hemisphere is a half-sphere, that is, 1/2 of a sphere sliced by a plane through its center. Let us consider a hemisphere with the radius r. The curved surface area of the hemisphere is equal to half of the area of a sphere. The total surface area of the hemisphere will be equal to the sum of the curved surface area and area of the flat circular end. The volume or capacity of the hemisphere is equal to half the volume of a sphere of the same radius. The space between two concentric spheres that have non-identical radii is known as a spherical shell. Let R1 and R2 be the inner and outer radii of a spherical shell. The outer surface area of the shell is 4 pi r2 square. The volume of the material can be calculated as In our daily lives, we may come across various objects like an ice cream cone, a tent, a test tube, etc., with shapes different than the basic shapes like sphere, cone, cylinder, and cuboid. These objects are a combination of basic shapes. For example, an ice cream cone may be considered a combination of two shapes: an inverted cone with a hemisphere on top, both sharing the same radius. The surface area of figures that are a combination of basic shapes, like sphere, cone, cylinder, and cuboid can be determined by calculating the surface areas of each basic shape separately and adding or subtracting as needed. Let us consider a rocket. A rocket is a combination of a cylinder and a cone. In the figure, ABCED is a rocket made of a cylinder ABCD and a cone CED. The radius of the cylinder and the cone is the same. The total surface area of the rocket is equal to curved surface area of the cylinder plus curved surface area of the cone plus base area of the cylinder. Tap the buttons to understand this better with more examples. Fill in the blanks with the correct values. 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 Let's summarize what we have learnt in this topic. The volume of figures that are a combination of basic shapes like sphere, cone, cylinder, and cuboid can be determined by calculating the volume of each basic shape separately and adding them. Let us consider the case of a pencil. A pencil is a combination of a hemisphere, a right circular cylinder, and a cone. Here, ABCDEF is a pencil made of the cone ABF, the right circular cylinder BCEF, and the hemisphere CDE. Tap the buttons to understand this better with more examples. Fill in the blanks with the correct values. 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 Let's summarize what we have learnt in this topic. We see various objects of different shapes in our daily lives. Some objects are converted from one shape to another for different purposes. Let us consider a solid ball of gold, melted and converted into two cuboidal-shaped bricks. The volume of the solid gold ball is the same as the sum of the volumes of the two gold bricks. When a solid is converted from one shape to another, its volume remains unchanged. Tap the buttons to understand this better with more examples. Fill in the blanks with the correct values. 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 We see various objects in our daily lives, like a glass tumbler or a bucket, that look like the portion of a cone. These objects form the shape of a cone left after cutting the top portion of the cone that contains its vertex. This type of shape is called frustum. Let us take the example of a paper cup. A paper cup looks like the remaining part of a cone after cutting its top by a plane parallel to its base. Here, ABCD is a frustum left after cutting a cone from its top by a plane parallel to the base AB. The frustum of a cone is a solid that is produced after cutting the cone with a plane parallel to its base. Let ABCD be a frustum of a cone with height h and slant height L. Let the radius of the base and the top of the frustum be capital R and R respectively. The volume of the frustum can be calculated as the slant height of the frustum can be calculated as, and the curved surface area of the frustum is, the total surface area of the frustum is equal to area of the flat circular base plus area of the flat circular top plus curved surface area. Tap the buttons to understand this better with more examples. Fill in the blanks with the correct values. 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 Let's summarize what we have learnt in this topic.